something and then print out the output to the screen. Okay. So, as I said, computers can only understand ones and zeros, right? So your main memory is the space where your computer stores everything, including your program, your values or your variable values and everything else, but everything in your memory is stored as ones and zeros. So these ones and zeros are called bits. Okay, so for example, let's say that you have your number system, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are your 10 values. So we call these 10 values as numeric digits, right? So digits comes from the fact that there are 10 things. So that's the deca from Greek. So digits. When you have 10 possible values, that is 0 to 9, you call them as digits. When you have ones and zeros, you just have two possible values, right? 1 and a 0. And you use these ones and zeros to represent everything possible. So for example, let's say that you want to represent the value 0. In that sense, you would represent that as, so if you want to represent the value 0, you will then represent the number 0 as, 0, right? Because you have access to ones and zeros, so you can represent 0 as 0. Now let's say that you want to represent the number 1, then we can use the other value, that is just 1, that is fine. Now let's say that we want to represent the value 2. Tell me, what can I use to represent the number 2 in terms of ones and zeros? Because I have already used up 1 and 0, right? So if I cannot use 0 and 1 again, so what we need to do is we need to represent the number 2 as 1, 0, right? So we are basically using two values, two different numbers. The first number is 1, the second number is 0, and we represent 2 as 1, 0. So in that sense, since we are using two digits, we need to represent 0 as 0, 0. We need to represent 1 as 0, 1, and then we can represent 2 as 1, 0. Perfect. Now, we have 0, we have 1, we have 2. 0 was 0, 0, then 0, 1, then 2 was 1, 0. How do we represent the number 3? Yes, so the next possible combination would be 1, 1. Right, so we have 0, 0, 0, 1, 1, 0, 1, 1. That represents your numbers 0, 1, 2, and 3. If we want to move forward, if we want to represent the number 4, that would be, so we have all the possible combinations that we can get from these two values, 0 and 1, in two different places. So then we have to represent the number 4 in 3 digits, right? So we have to represent the number 4 as, we can't do 0, 0, 0 because 0, 0 is already taken. So what we need to do is we need to write it as 1, 0, 0. So in that sense, we would need 3 different values to represent the number 0, 1, 2, 3, 4. Any number between 0, 1, 2, 3, 4, we need 3 different values, and it goes forward like that. So when you write something, when you write something in terms of binary values, you only have access to these 2 possible values, that is 0 and a 1. Now, somebody asked the question that how would you represent negative values? And that is a very good question. We can represent negative numbers in terms of decimal values as simply, let's say, minus 10 was a bad choice of number. So let's say minus 5. So we can just write minus 5, and there you have your negative numbers. Now, let's say that I want to represent, let's say, minus 4. In your this two value system, 1 and 0 value system, right? So in that case, what your computer actually does is it saves one value, or it reserves one value to depict whether something is positive or negative. So a number can either be positive or a number can either be negative. So in that case, you have two possible choices, right? One is a positive sign, one is a negative sign. So if there are two possible choices, then I can represent the number, let's say positive 4 as some, so we have your positive 4 as 100. I can also reserve one more value, that is, let's say 0 is positive, 1 is negative. So I can say 0100 is going to be positive 4. And if I want to now represent negative 4, I can then just say 1100 is negative 4, where now 1 represents the negative value. Does that make sense? Okay. Now I say that zero, you just add a 0 and a 1 in front, and that makes it a positive number and a negative number. And that is true in some respect, but your computer actually stores negative numbers slightly differently. And you will learn about those if you take an assembly language class or actual machine code class, where you learn to write programs not in high level languages but directly into machine, right? Those ones and zeros and assembly languages. So that is so how a computer represents something as a negative number is not important for this class, but just remember that there is something called a 2's complement. A 2's complement is something where your computer stores your negative numbers in terms of ones and zeros, but not just having a bit that says 1 or 0 that represents positive or negative, but it converts the number into some other number that represents a negative. So you don't need to bother about that as of yet. If you want to know more in detail, I'll talk to you about that sometime later. But in general, your computer, just remember that your computer stores everything in terms of ones and zeros, even negative numbers. And for that matter, numbers are stored as ones and zeros, even decimal values. So for example, the value of pi, 3.14 and whatever, that decimal value thing is also stored in terms of some binary or two value system representation. Even characters or strings. So for example, sentences or this text, right? This text itself is again converted into some set of numbers, and those numbers are then stored into your computer in terms of ones and zeros. So when I say that digits are your 10 different values, 0 through 9, so your so deca, or your decimal values or deca numbers, we call them digits. Similarly, when we talk about computer numbers, we are talking about two value systems, so we call them as binary digits, right? So in short, we also call them as bits, binary digits, right? So if we have a set of bits or binary digits, we can then use those to represent something. So for example, your numbers from 0 through 4 were represented in 3 bits, right? So the positive 4 and the negative 4, for our example, were represented in 4 bits. Okay. In computer terminology, usually a set of 8 bits are called 1 byte. 4 bits are called nibble, and 1 bit is 1 bit. So a nibble is basically half a byte, pun intended. So that is, a nibble is 4 bits, and a byte is 8 bits. When we talk about computer systems, a computer will not process everything bit by bit. It will usually process everything in terms of chunks of bits, right? So when we say that this and this new processor is 64-bit processor or a 32-bit processor. That is the chunk size that your processor processes in one go. So when I say 64-bit, your computer can read 64 bits of information from your RAM or your main memory at a time, and then processes it step by step, and then moves on to the next 64-bit information, and then moves on to the next, and so on. So, as I said, everything in your computer system is represented in terms of numbers, right? So whenever you write a program, your computer distinguishes between three types of values, because everything in your computer is represented in numbers. It has no idea whether you are talking about so let's say that the sentence hello world, the sentence hello world is also represented in terms of numbers, and also some other set of numbers are also represented as numbers. So your computer needs to distinguish between these two types of values, right? So your computer needs to know that, okay, this is a number value and this is a sentence or a string, right? Or a character. So whenever you write programs, you would need to mention specifically that, okay, I'm talking about this as a sentence. I'm talking about this as a number. So when I talk about something in terms of numbers, I have two options. One is an int or an unsigned int. So int and unsigned int, and we'll talk about these in more detail later. These are what we call data types. So you have three main data types. One is an integer data type, one is a floating point data type, and one is a character type data type. Integer type data types are used to store or work with just integers or numbers. So 1, 2, -1, -3, 8, 100, those complete numbers, right? Whole. Then we have your floating point numbers, which are your decimal values. So the value of pi, for example, 3.14 something. So something dot something 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 are represented as floating point values or double values. Then we have your characters. Characters are essentially self-explanatory. You have your letters or alphabets, A, B, C, D, and so on. The hashtag sign, the star sign, all of those things are characters. So when I talked about bits and bytes, so integers in general are usually represented as 4 bytes. Floating point values and floating point values also have 4 bytes. A double value is represented in 8 bytes. A character is represented in 1 byte, right? So, and what do I mean when I say that something is represented in terms of bytes? So let's say that we have just a system where integers are represented in 2 bits. Nothing more. So remember, integers in your computer are represented with 4 bytes. So 4 bytes means 4 times 1 byte. And we know that 1 byte is 8 bits. So we have 4 times 8. So it is in total 32 bits. So each integer is represented in your computer as 32 bits. Now that gives you certain restrictions. So let's say that your computer has reserved only 2 bits for your integers. That means that I can have 00, I can have 01 as my 2-bit values, I can have 10